For what, 50 years, we've basically had one big metaphor for the brain. It's a computer, right? But what if that's just not the whole story? What if the key to understanding our minds isn't about the software, but about the actual physical stuff the brain is made of?
I mean, you've heard this a million times. The brain is like a biological computer processing information. It's a useful idea for sure. But what if that metaphor, as helpful as it's been, is actually holding us back? What if the real secret to our thoughts, our dreams, our creativity isn't in some abstract code, but in the physical hardware itself?
So, this really frames the debate perfectly. On one side, you've got the classic computer brain. It's all about logic gates, circuits, ones and zeros. But on the other side, there's this really fascinating new idea, the material brain. And this theory, it's not about code. It's about the physical medium of the brain. Its waves, its textures, and this really cool property we're going to dive into called viscoelasticity. The whole game shifts from just processing information to physically shaping a medium.
And here is the absolute heart of it. The idea is that our mind, our consciousness, our thoughts, isn't just some ghost in the machine. It's not abstract software running on neutral hardware. It's an emergent property of the brain's physical stuff. Yeah, the very squishiness and springiness of our brain tissue might be the key to how we think. Wild, right?
Okay, so to really get our heads around this, we have to look at the brain from a new angle, a kind of Goldilocks zone for the mind. Scientists are calling this the Mesoscopic middle ground. Let's think about it like this. You can look at the brain on 3 different levels. Way down at the bottom, you have the microscopic level. That's just individual neurons firing away. And way up at the top is the macroscopic. That's our conscious experience, our thoughts and feelings. But this new theory says the real magic, the missing link, happens smack in the middle, at the mesoscopic level. This is where the brain stops being a collection of cells and starts acting like a single collective medium.
So what exactly is this mesoscopic level? Well, it's the scale where billions of individual neurons stop acting like separate little sparks and start behaving together more like a wave moving through water. Their collective behavior creates what you could call a self-organizing medium. And here's the key part. It's the physical properties of this medium that might be the bridge between a single neuron firing and, say, a rich, complex memory.
This quote from the research just nails it. It's not about a mind and a brain that somehow interact. No, it's one single system that we can look at in 2 different ways. You've got the physical coordinates, that's the neural activity, and then you have the coordinates of our experience, our thoughts, feelings, what scientists call mentation. It's kind of like having 2 different maps, say a political map and a topographical map, of the exact same piece of land. 2 views, 1 reality.
Okay, so if it's one physical system, then what are its physical properties? This brings us to the actual physics of our thoughts. Or, to put it a little more simply, how the squishiness of your brain literally shapes what you're thinking right now.
The hero property here is a fantastic word called viscoelasticity. It sounds complicated, but it just means our brain tissue has 2 qualities at the same time. On one hand, it's elastic, like a spring. It can store energy and bounce right back into shape. But it's also viscous, like thick honey, meaning it's fluid-like and it resists motion, dissipating energy. So your brain is both springy and gooey. And that combination, it turns out, might be absolutely crucial.
Let's break that down real quick. The elastic side, the springiness, is what allows for stability and order. It stores energy and lets waves of activity travel coherently across the brain. That's your focused, stable thought. The viscous side, the gooey part, on the other hand, is all about change and flux. It dissipates energy, allowing thoughts to break apart, shift, and recombine into something new. That's your creative spark, your mind wandering off on a tangent.
And this just shows that trade-off perfectly. When the brain's medium is more elastic, it's way better at holding onto a single thought, which is exactly what you need for focused attention. It's like your deep work mode. But when the medium becomes more viscous, energy scatters faster. This makes it easier for your mind to jump from one idea to another, a process researchers call basin hopping. And this physical state? Well, that's what fuels creative daydreams and the absolutely bizarre landscapes of our dreams. So here's the million-dollar question. Can we actually connect these physical properties to our everyday mental states? Let's take a look at how this theory could map the physics of the brain to everything from being laser-focused at work to having a totally wild dream. And this really is the huge payoff. If we stop treating the brain like a computer and start treating it like this dynamic, viscoelastic medium, we might finally get a direct, physical map,
a map from the texture of the brain to the actual texture of our thoughts.
Okay, this is where it all clicks into place. Look at this. When you're in a state of focused wakefulness, the brain's medium is highly coherent, like a tightly stretched drum skin. It holds one thought stable, and your experience feels controlled, like a narrow story. Now, when you're in a relaxed state, maybe just daydreaming, the medium loosens up. It allows for that basin hopping, and your mind starts making loose associations. Then you get to REM sleep. Here, the medium supports rapid, high-energy basin hopping, driven by internal signals, creating those vivid, emotional, and frankly weird dream scenes. It's a direct line from the physical state of your brain to what it feels like to be you.
So this is way more than just a cool idea to think about. It really represents a whole new frontier for research, one that's trying to take centuries of philosophical debate about the mind and turn it into actual testable science. And that is so important. This material brain idea isn't just swapping out the computer metaphor for a new one. It's a real scientific framework. It generates predictions, hypotheses that scientists can actually go into the lab and test, and maybe even prove wrong, which, is the whole point of good science. And it leads to some absolutely fascinating questions we can now ask. For example, could we actually measure a region of your brain tissue getting physically stiffer when you're super focused on a task? Could we watch the brain's material properties literally shift as you fall asleep and start to dream? And get this, could a person's unique brain texture, their baseline elastomy, predict their cognitive style? Whether they're naturally a more stable, focused thinker versus a more flexible, creative one. These aren't science fiction anymore. These are questions we can actually start to investigate.
So I'll leave you with this final thought. If our mind, our very sense of who we are, is a pattern that emerges from a physical medium, like a wave moving across the surface of water, what happens when that medium changes? When it changes with age, or with disease, or even just from moment to moment as we think and feel? It completely reframes the connection between who we are and the physical stuff that we are made of. Pretty incredible to think about.